Hey, welcome back, 8th grade. We're going to be pushing into problem 2.3 today in our book, It's in the System. And we're going to explore that method of elimination that we came up with in 2.3, or 2.2, sorry. And we'll use that strategy and approach in these today. Let's take a look. All right, solving systems by combining equations. That's that process of addition or subtraction, which we'll see here today. So Pablo and Jasmine showed their method for solving system of linear equations. Their teacher then asked the class how they would solve the following system from problem 2.2. And so we have a 2x minus y equals 4 and an x plus y equals 5. So their classmate Samantha offered this solution. So if 2x minus y equals 4 and x plus y equals 5, then notice how she takes this piece down, puts it here, this piece down, puts it here, and looks to add them together. And then the 4 plus 5 comes in that case as well too. So now look, we've got a 2x and an x being added together. We get that. And then we've got a minus y and a positive y. That cancels out. And then we've got this coming out to be 9. So we've got 3x equals 9, dividing by 3 on both sides, then plugging that 3 back in. You get that. That's what we had before. We had that the value of x was 3, the value of y was 2. So we're going to play around with this strategy here today. Now, one thing that we did notice in that problem from the other day is that we ended up subtracting the two sets of equations together. And that was a big factor. But now we're going to actually have two items or two of the parts of the function. They're going to be opposites. So you're going to see, like what we saw here, we had the minus y and the plus y. That will end up canceling out. So in this term, we'll add them together. And then those guys will cancel out as it is. So let's take a look at that today. All right, so we're asked to use the methods of Pablo and Jasmine and Samantha to solve each system. So what we saw before is, remember when these guys were the same, we ended up writing the minus sign, but now because we do have opposites here, we have these guys that will cancel out, we're gonna actually in turn add them this time. So these guys will be canceled out because a negative x plus that positive x is gonna be gone. We're gonna have a 4y plus 2y is gonna be a 6y. And then I'm going to count these guys up, and it's going to be equal to 7. And that's what we have here in this case. Divide by 6, divided by 6. Turns out that y is equal to 7/6. And we'll leave it that way. That's totally fine to work with, and we'll use that there. Now we're going to take that and plug it back in. Now I like this one here because it's a smaller number for multiplying, but we'll play with this one because also it's a positive x here too. So I'm going to put that in here. So I'll have here x plus 2 times 7/6 equals 5. That means I'm going to have x plus, this will end up being a, you can cross cancel here. This will end up being a 1, this will be a 3. So that means that we're going to have a 7/3, because it would have been just like a 14/6, which simplifies down to that 7/3 equals 5. And we need to subtract the 7/3 and subtract the 7/3. And it's going to be, so x equals this. Now there's where we go back to our work that we did back in 5th grade where we have to work with changing this into a mixed number. So now I'm going to have a 5, but this would end up being 7 divided by 3 is going to go in 2 times with a 1/3 left over. So let's do that subtraction here. So then I'm going to do this, subtract it. So it's going to end up being a borrowing feature going on. I'm going to have here, this will be a 4, and I'll bring my 3/3 down. So this will be 3/3 minus 1/3 is going to be 2/3, and then 4 minus 2 is going to be 2. So we could leave that as a 2 2/3 or keep it as that improper form. This would end up being an 8/3. Either of these would work in that case. So those are our two values. All right, number 2. Now notice we don't have the opposites like we had here. The opposites, we just added them, but here we have the same. So in this case, we're going to actually do some subtraction, okay? So think about it like this. 2x minus 5x is going to give me that negative 3x. 3y minus 3y is going to give me that 0. And be careful on this one. 4 minus negative 8. Remember that minus and negative ends up acting like it's a plus or it's a positive, so it becomes 12. So a 3x is equal to 12. Subtract by 3, or divide by 3, divide by 3. Negative 3, x is going to be equal to negative 4. So that is our value of x. Let's go back here and plug it in. I like this top one better because I don't have to worry about the negatives so much. So I'll have a 2 times negative 4 plus 3y equals 4. This will be a negative 8 plus 3y equals 4. So let's add 8 and add 8. 3y equals 12. Hey, look at that. And now we'll divide by 3, divide by 3. Y equals 4. So there are our answers. X equals negative 4, y equals positive 4. Number 3, 2x minus 3y equals 4, and 5x minus 3y equals 7. Okay, so we don't have opposites. So remember how we didn't have opposites up here? We end up having to subtract, but we gotta be really careful here, again, because we're gonna be working with this particular setup here. And we gotta be careful with subtracting again. So here it is again. 2x minus 5x is going to give me that negative 3x. Negative 3y minus the negative 3y will make that be like a plus. So this ends up being 0. And then we have 4 minus 7, which is going to give me that negative 11. I made a mistake. 4 minus 7 is going to be a negative 3. My mistake. All right. So then what we do is we rewrite this. That's going to be a negative 3 divided by negative 3 divided by negative 3. Turns out that this is going to be x equals a positive 1. And that's our value of x. So let's go ahead and plug that back in. And both of these are going to be pretty easy, but I like the times 2. So we'll do 2 times 1 minus 3y equals 4. So this is 2 minus 3y equals 4. So minus 2 minus 2. I'm going to have a negative 3y equals positive 2 divided by negative 3 divided by negative 3. Turns out y equals, and there it is, it's going to be a negative 2/3. And that is our answer. All right, number 4, 3x plus 2y equals 10. And 4x minus y, sorry about that little spot there, equals 6. Whoa, this one's a little bit tricky. We don't have anything there that we can cancel out. There's nothing to work with in this case. So we've got some couple options, but this is a newer strategy. Is there anything I could do to turn this y into a 2y? There actually is. I'm going to rewrite this one over here because I like this top one. But what we can do is we can take all of this, because we want this to be a minus 2y. So if I can turn this into a minus 2y, that will work. As long as I do everything all the way through, I can multiply all of this times 2, and it would still work. So in this case here, what we're going to actually do is distribute the 2. So 2 times 4 is going to give me an 8x. 2 times that negative y is going to be my minus 2y equals, and this is going to give me 12. And it doesn't matter that we add that as long as we keep it consistent all the way through. So let's do that here and check that work out. So now, because these are opposites, I'm going to add these guys together. So 3x plus 8x is 11x. These guys will cancel because they'll be gone, so it's going to be plus 0. And then these guys will equal 22. And I like that. It's going to be some warm fuzzies there. So 11x equals 22. Divided by 11, divided by 11. X will equal 2. Let's go back and plug that in here. I like this top one here. So 2 times, so it'd be 3 times 2 plus 2y equals 10. 6 plus 2y equals 10. Minus 6, it's gone. 2y equals 4. Divided by 2, divided by 2. Y is going to equal 2. And there it is. Hey, look at that. 2 and 2. All right, part B. In the t-shirt and cap cell, the equation 5s plus 10c equals 125 related the profit to the number of shirts and caps sold. Find 5 solutions to the equation. All right, so 5 solutions. Remember, we're just going to take some numbers and plug them in and see what we get. So I'll start off with 0 here. So if I put 0 in here, 0 times 5 is going to be 0 plus 10c equals 125. Ooh, this one's not going to work. Look at that. Because if I end up dividing 125 divided by 10, I'm going to get a decimal. I can't get part of a cap. So this one's not going to work. So let's not play with that one at all. Let's put 1 in. What if I get 1 shirt? So basically 5 times 1 would be 1 equals 10c plus there is 125. So that's going to be 5 here. So minus 5 and minus 5, that's going to give me 10c equals 120. divide by 10, divide by 10. So C would equal 12. So it looks like we're gonna need odd numbers for this, because if I put 2 in here, that's gonna keep giving me that same issue in that case. So I'm gonna go ahead and I'm gonna skip the 2. I'm gonna put in a 3. So I'll put 3 in here now. So 3 times 5 is gonna be 15 plus 10C equals 125. If I subtract the 15 on both sides, I'm gonna have 10C equals, this is gonna be 0, it's gonna be 110. Divide both of those sides by 10. Hey, I'm gonna get 11. Hey, let's give it a little bit of a pattern there. Look at 1 was 12, 3 is 11. So if I go this way, if I do 5, I bet you it's gonna end up being, this is gonna be 1 less, it's gonna be 10. Let's just test that to be sure. So 5 times 5 is gonna be 25 plus 10C equals 125. Look at that, minus 25, minus 25. 10C equals 100. Yep, dividing by 10 would give me that pattern there. So I'm gonna go use that pattern there. So I'm gonna have a 7 and then a 9. So it's gonna end up being 9 and this will end up being 8. See how that works? It's that same pattern. So there are our 5 solutions. All right, B2. Samantha said, if we double the price of each item, we would have doubled the profit for the same number of shirts and caps. Do you agree with this reasoning? Why or why not? Let's think about that. If we took the caps from, the shirts from $5 to $10, and the caps from $10 to $20, those are doubled. So it's kind of like a scale factor type of thing. It's times 2, times 2, times 2, all the way. So it ended up being $250. So yeah, that makes sense. I agree with her reasoning. Sure. Nice job, Samantha. All right, B3. Write Samantha's new equation. Check whether the solutions from part 1 are all solutions to the new equation. So Samantha's equation of doubling everything would be, instead of 5s, it'd be 10s plus 20c. Is that gonna end up giving us the 250 that we're thinking about? So let's take a look that each of these solutions work. So our first one was 1 and 12. Let's see if that ends up being the case. So if I get 10 times 1 plus 20 times 12, does that equal 250? Well, 10 plus 20 times 12, oops, excuse me. $20 times 12, 240. Yeah, that one works. Let's check the others. So 3 and 11, so that's gonna end up being, I'm gonna skip some steps here, that's gonna end up being 30 plus, let's do 20 times 11. I should use my calculator right away. 20 times 11, oops, 20 times 11, 220, yeah. 30 plus 220 equals 250. Yeah, it's gonna work for all of them. So it turns out it's going to work perfectly because we did a scale factor of 2 on all those, and those same solutions would work in that case. So the values of 5, 10, 7, 9, and 9, 8 would all work too.